everyone, welcome to Genius Classes. So, before beginning with the actual topic, we must first know the meaning of trigonometry. The word itself is divided into three parts: trigonometry. So, tri means three, gom means sides, and metry means measurement. So, in this chapter, we are required to find the measurement of three sides of a triangle. And the triangle here is always supposed to be a right-angled triangle. Yes, so we have a right-angled triangle, ABC, right angle at B. If ever we are given two sides of a triangle and then we have to find the third missing side of the right angle triangle. Suppose we are given one side to be 3 and the other is 4 in this triangle, and we are asked to find the missing side. So we have already studied earlier Pythagoras theorem. We can apply it directly. And in right angle triangle, the longest side is known as hypotenuse. This is known as perpendicular. And the side on which the triangle is standing is known as base of triangle. So we can easily apply Pythagoras theorem, which says that square of hypotenuse is equal to the sum of squares of the other two sides. Now we are given AB as 3, BC as 4. We can put the values here. AC square equal to AB 3, 3 square plus BC 4, 4 square, 9 plus 16, which is 25. So our AC square is 25. From here we get AC to be 5. So using Pythagoras theorem, we can easily find the missing side of a right angled triangle if two of its sides are given to us. So to begin with the actual trigonometry, we have to find the trigonometric ratios. We have to find the ratio of the two sides of a triangle. And how we can find out them is, suppose we have a right angled triangle in which two sides are given to us and we have to find the missing side along with the trigonometric ratio. So we already know using Pythagoras theorem we can find the missing side of a right angled triangle directly. But to find a trigonometric ratio, that means we have to find the ratio of two sides of a triangle using some trigonometric angle. Now starting with the actual trigonometry, we have 6 trigonometric functions: sine A, cos A, tan A, and the reciprocal of sine A is cosec A, reciprocal of cos A is sec A, reciprocal of tan A is cot A. So in a right angle triangle, we are required to find these ratios. Now this is read as sine of angle A, cos of angle A, tan of angle A, similarly cosec of angle A, sec of angle A, and cot of angle A. We can find these trigonometric ratios with respect to other angles as well. I have used angle A, you can name it as P or any of the required angle. Now sine of angle A is completely single quantity. We cannot separate sine and A. Sine without A is useless. A without sine is nothing. Sine of angle A is complete a trigonometric ratio. Now we have a right angled triangle. Let's suppose this only. One side is 3 and the other one is 4. We are naming this triangle triangle as ABC, here A and this side C. B is our right angle. And we are required to find the ratio of sine A. Now, to find this ratio, we have the formulas. Sine of A is perpendicular side of triangle with respect to angle A divided by hypotenuse. Cos of angle A is base upon hypotenuse and tan of angle A is perpendicular upon base. Now, the main thing to be considered while calculating sine, cos, tan or any of the trigonometric ratio is we are always finding these ratios with respect to an acute angle. So here A is our acute angle. We can only apply these trigonometric ratios with respect to acute angles. So we are considering A angle here. So in this triangle, we have to find the value of sine A. How can we find it? Sine A is perpendicular upon hypotenuse. So with respect to this angle, perpendicular of this triangle is BC and hypotenuse is side opposite to this right angle, which is AC. Now, for the first part, we can find the missing side using Pythagoras theorem. We have already calculated it as 5. Now, to find the ratio, we can simply put the value BC is 3, AC is 5. So, our sine A is 3 upon 5. Similarly, we can find the other ratios. Cos A base upon hypotenuse. Base is 4, hypotenuse 5. Similarly, tan A perpendicular 3 upon base 4, 3 upon 4. But if we are asked to find the value of sine C in this triangle, so we cannot directly take sine C and write the same perpendicular and hypotenuse. Now we have to find the perpendicular and hypotenuse with respect to the angle C. We can simply rotate the triangle towards right. And the new triangle can be formed as right angle at B, same, interchanging A and C. Putting the same values, AB now is 4, BC is 3 and AC is 5. So considering angle C, with respect to angle C, our perpendicular is AB and hypotenuse is AC. So value of sine C is AB is 4, AC is 5. 4 upon 5. Similarly, we can find cos C, tan C, cosec, sec, cot, all the trigonometric ratios. So, this was the basic of trigonometry that we must know before starting with the actual questions of the topic. Now, let's solve a question in which we are given if sine A is 3 upon 4, find cos A and tan A. So first we'll form a right angle triangle. And we are finding the ratios with respect to angle A. So we will put angle A this side. This we can name as ABC. This is a right angle triangle and in which we are given sine A is 3 upon 4. So we know that sine A is perpendicular upon hypotenuse. We can put it equal to perpendicular BC upon hypotenuse AC. This is our sine A, but to keep in mind is we are given the ratio. We are not given the actual measurements of side BC. We cannot equate it straight away that BC is 3 and AC is 4. So whenever we are given the ratio of two sides, we are required to use a constant. So we can write let BC is 3 times of a constant K, AC is 4K. So our BC is 3K, AC is 4K. and we have to find cos A. So for cos A, we should have base upon hypotenuse. So first we are required to find the measurement of side AB. We can easily find measurement of side AB using Pythagoras theorem. Square of hypotenuse is equal to sum of squares of the other two sides. AC is 4k, 4k square equal to BC is 3k, 3k square plus AB square. You have to find AB. So 16k square minus 9k square equal to AB square. 7k square equal to AB square. From here we get AB equals to k root 7. So we have found the value of AB, which is k root 7. Now we can find cos A. Cos A is based upon hypotenuse, base AB, hypotenuse AC. AB is k root 7. AC is 4k. We'll cancel out k and the answer is root 7 upon 4. Similarly, tan A is perpendicular upon base, perpendicular BC, base AB. So BC is 3k and AB is root 7k. Cancel out k, we get tan A is 3 upon root 7. So this is the required answer. Now, let's consider another question. We are given in triangle OPQ, right angled at P, OP is 7 cm, OP is 7 cm, and OQ minus PQ is 1 cm. Determine sine of Q and cos of Q. So, with respect to Q angle, we have to find sine Q and cos Q. So, first of all, we have to find the measurement of the missing sides. Simply by Pythagoras theorem, we can find them. So by Pythagoras theorem, hypotenuse square is equal to the sum of squares of the other two sides. And the relation we are given is OQ minus PQ is 1. From here we can write OQ as 1 plus PQ. So here we will replace OQ with 1 plus PQ. 1 plus PQ whole square equal to OP is given 7 square plus PQ square. Using the identity A plus B whole square equal to A square plus B square plus 2AB, we can apply it for this bracket. So 1 plus PQ square plus twice of PQ equal to 49 plus PQ square. We can cancel out PQ. It will come to this side. The sign will be changed. Negative. So positive and negative are cancelled. From here we get twice of PQ is 49 minus 1 48, and our PQ is 24 centimeter. Now we can find the value of OQ as well. OQ is 1 plus PQ. PQ is 24. So our OQ is 25 centimeter. Now we have PQ 24, OQ 25. And we are required to find the value of sin Q and cos Q. Sin Q is perpendicular upon hypotenuse, perpendicular OP upon hypotenuse OQ. So perpendicular OP is 7 and OQ is 25. This is our sin Q, and cos Q is base PQ upon hypotenuse OQ. So PQ is 24 and OQ is 25. This is what we are required to find. So this is our required answer. Thank you.